Hi everyone. In continuation on our series on polynomials, today's tutorial has the question x cubed plus x squared is equal to 12 to solve for x. Okay, this is actually a polynomial of degree 3. X cubed plus x squared is equal to 12. It's a polynomial of degree 3, so we expect to have 3 solutions. So the first thing to do is to remove this constant from the right hand side to the left hand side so that we'll have a 0 on the right hand side. So we get x cubed plus x squared minus 12 equals 0. Alright, so now this is x cubed, this is x squared. Inside 12 here, we can bring out 8 and 4. 12 is actually 8 plus 4. Why 8? Because 8 is 2 cubed, so we'll pair it with this cube. And 4 is 2 squared, we can pair it with this square. That is the reasoning here. The other way around was 2. The other way around is 2. We carry out what we call trial and error method, wherein we keep testing values from plus -1, plus -2. The one that will render this 0, it will be a root. And from the root, we can form a factor. Then from there, we carry out Euclidean division to obtain a quadratic equation that can be solved using the quadratic formula. Okay, so that is the other method, but here we see that 12 can be written as 8 plus 4. Okay, we are written 12 as 8 plus 4. Remember, this is -12. This is the same -12. All right, 8 is 2 cubed, 4 is 2 squared. We can pair them up there and use the difference of cubes and difference of squares identities. All right, let's open the parentheses. We have x cubed plus x squared. Open that, we have -8. Open that, we have -4 equals 0. Now we take this -8 and pair it with that. So we have x cubed minus 8 plus x squared minus 4 equals 0. All right. Now at this level, we know that 8 is the same as 2 cubed. So this one is x cubed minus 2 cubed, and 4 is the same as 2 squared. Okay, so if we do this, then you see we end up with a difference of cube, a difference of squares, and we know the identities. So we just go ahead and apply the identities of difference of cubes. The identity of difference of cubes, again, remember a cube minus b cube. According to the identity, it is a minus b into a squared plus their product, ab plus b squared. That's the identity we're going to apply here. Our x is a and our b and our 2 is b. Okay, so let's apply that. So we're going to have x minus 2 into x squared plus their product, 2x plus 2 squared, which is 4. Okay, that is it for the difference of cubes. And then here, difference of squares identity, a squared minus b squared is the same as a minus b into a plus b. All right, so x will be a and 2 will be b. So remember, it is plus there. So plus. So in the place of that, we're going to write x minus 2 into x plus 2 is equal to 0. Okay, we have transformed that into this long expression using the difference of cube and difference of squares identities. Okay, now we find x minus 2 here and x minus 2 again there. So it is common in the two expressions. Remember, the two long expressions are separated with this, are separated by this plus sign, this addition sign. This long expression separated from this other long expression by this addition sign. But we have a common factor. There is x minus 2 here and there is x minus 2 there. So we'll factorize it out. We'll factorize out x minus 2. Okay, it means when it goes away from here, we'll have this one. We'll have x squared plus 2x plus 4. Okay, When we remove x minus 2 from here, we have x plus 2. Okay, that's what we get. All right. So finally, we have the product of two expressions giving us 0. Remember, when two expressions multiply to give us 0, either the first one is 0 or the second one is 0. Okay, all right. So this is like your A, this is your B. They have been multiplied together to give us 0. So either x minus 2 is 0. If that is the case, it means x equals 2 is our first solution. All right. Or this other one is equal to 0. Or x squared. This is 2x plus x 3x. Then 4 plus 2, 6. Okay. We have simplified this here. X squared, 2x plus x is 3x, and 4 plus 2 is 6. All right. So we've solved that one. Then all this one is also equal to 0. Now look at this. This is a polynomial of degree 2, which is a quadratic equation. It must give us the remaining two solutions. And so we want to apply the quadratic formula. Our A is the coefficient of x squared term, B is the coefficient of the x term, and our C is the constant. So we know the quadratic formula, x equals minus b plus minus the root of b squared minus 4ac, all of that divided by 2a. So putting A, B, C in there carefully, we have x is equal to negative 3 plus minus the root of 3 squared minus 4 into A into C, all over 2A. So our x is equal to negative 3 plus minus the root of 3 squared is 9. Okay. 4 multiplied to 1 is 4, multiplied to 6 is 24. 9 minus 24, all over 2 multiplied to 1 is 2. Okay, so we obtain negative 3 plus minus 9 minus 24 is negative 15. Negative 15 all over 2. Now, what is the root of negative 15? This is not a real number because square root of negative numbers do not exist in the set of real numbers. So, but it exists in the set of complex numbers. So we'll evaluate this as root of negative 1 multiplied to 15. Applying the rules of search, we'll have root of negative 1 multiplied to root of 15. Root of negative 1 is the imaginary number I, and then of course we just attach the root of 15. Okay, so root negative 15 is I root 15. Okay, now we put that now in. So we're saying x is equal to, we're putting it there, negative 3 plus minus I root 15 all over 2. Okay, so this gives us the remaining two solutions. Okay, so finally our solutions are: the first one, x is equal to 2. The second, x is equal to negative 3 plus I root 15 all over 2. And the third, x is equal to negative 3 minus I root 15 all over 2. Okay, so if you go and want to check if this solution, this one is real, these other ones are complex. So we have one real solution and two complex solutions. if you go ahead, you want to check the real solution, if it is actually true. All right, all we need to do is to put it here on the left hand side of this expression to see if we obtain the right hand side. So if you put x equals 2, all right, in x cubed plus x squared, let us see if we're going to obtain 12. 2 cubed plus 2 squared. 2 cubed is 8, 2 squared is 4. Okay, and 8 plus 4 is 12, which is our right hand side. So that proves that x equals 2 is the real solution of that cubic equation. And these other ones are the complex solution of the same cubic equation.